Okay, so warm-up problem for you today. You've done it a bunch of times, so shouldn't need any explanation on how to do that. But so let's start with that one. All right, so while you guys are finishing up this warm-up problem, let me just talk a little bit about this week. You do have a formative tomorrow, and you have a quiz on Friday. Okay, so formative tomorrow, quiz Friday, and then a chapter test next week, Wednesday. Okay. So, thinking back to Algebra 1, what are some of the ways that we know how to solve this system of equations? Elimination's one of them. Substitution's one of them. There's one more. While we're thinking about that one more, graphing would be the other one. Yep. Okay, so those are the three ways that we know how to solve it. So, if we were graphing, what would we have to do?
Put it in y equals mx plus b form and plot it.
Plot it, and then what are we looking for?
Where it intersects.
Where the two lines intersect. Yep, because they're both lines. Love it. Okay? If we're substituting, you said substitution, right, Shaquille?
Yeah.
Okay, if we're substituting, what do we got to do?
Maybe the 3x by itself or something, or the x, you can get the x by itself and then plug it.
Get one of the variables by itself,
Yeah.
right? Okay, in one of the equations, and then substitute that variable back into the other one. Okay, then we solve that new equation, and then we take that new value and plug it back into one of the original ones to get the other one, right? Okay, love it. If we are eliminating, what do we do?
Multiply one of the equations so that
Or
the
both,
variables,
right?
Yeah, so
Yep.
the variables at least one, just one of the variables cancels out, so then you can solve for the variable left over.
So, and then plug back in and same thing. Yep. Okay, and then that's going to give us our point, right? Okay, love it. Okay, so I love the elimination, so I'm going to go with elimination. Okay, of those three. So I'm going to multiply this bottom equation by -3. That gives me a top equation of 3x plus 4y equals 1. That gives me a bottom equation of -3x plus 30y equals -18. And then I am going to add those two equations together. And that gives me, the x's cancel each other out, gives me 34y equals -17. Divide both sides by 34, gives me y equals -1/2. Then I'm going to take -1/2, and I'm going to plug it back into one of the original equations. I'm going to pick the top one. In place of y, and that's going to equal 1. So that's going to be this one. 3x minus 2 equals 1, and that gives me 3x equals 3, so then x equals 1. So the solution to this system of equations is potentially 1, -1/2. But what should I do to make sure that I'm right?
Plug both of the numbers, variable numbers back.
Into one equation? Both equations. Yep. So I'm going to plug those two numbers, put 1 in for x and -1/2 in for y, back into both equations. So 3 times 1 is 1. 4 times -1/2 is -2. 3 plus -2 is 1, so it checks out in the first one. 1 is 1. 10 times -1/2 is -5. 1 minus -5 is 6, and 6 is equal to 6. So it checks out in the second equation. So yeah, we got it. Okay? Love it. So, in previous classes, in previous chapters, we solved linear systems of equations. That's exactly what we just did. We said we can solve them by graphing. We can solve them by substitution. Or we could solve by elimination. We just talked all about all those. Okay? So those are the tools that we have in our toolbox. We would also, had we not had 8 snow days this year, we would also have in our toolbox Cramer's rule and solving by matrices. Okay? But those two methods were eliminated because we needed 8 days to get through everything else that we needed to get through. And this is what we had to get through. Okay? All right? So today, then, what we're going to start is we are going to start quadratic systems. A quadratic system is a system of equations that contains at least one conic. Okay? So we might have a circle and a line, or 2 parabolas, or a parabola and a line, or a parabola and an ellipse, or 2 hyperbolas, or a hyperbola and a circle, okay? Or a hyperbola and a line, or an ellipse and a line, or whatever. Okay? One of the 2 equations is a conic. Okay? Now, how do you think we're going to go about solving quadratic systems of equations? What are some possible methods that we might have? Graphing is one of them. But that's not always necessarily the most accurate one because we've kind of been loosey-goosey with our graphs, right? Okay, so but that is a way. What's another one? Substitution might be a way. And elimination might be a way. Okay? And so today what we're going to focus in on is we're going to focus in on the substitution aspect of it. Okay? We'll check it actually by graphing and by plugging stuff back in. But we're going to focus in on substitution. Tomorrow you'll have a formative. Wednesday we'll focus on elimination. Okay? Thursday, I don't remember what we're doing Thursday, and Friday we're taking a quiz. Okay? All right? So let's start with the basic forms of conics. You've seen these before. Okay? We did parabolas 5 weeks ago. Then we did circles 4 weeks ago. We did ellipses 2 weeks ago. And we did hyperbolas last week. Okay? So we've seen all those before. So that's what's going to come up. And then on top of all of that, we're going to have y equals mx plus b as a possibility on there too. Okay? Because that might be what the intersection is going to be. Okay? So, if I am going with substitution, okay, first off, I am going to solve one equation for x or for y, which was what you guys just told me was the steps to substitution of linear equations. Solve one of the equations for one of the variables. Okay? Again, way back, actually this was at the start of second semester when we refreshed this stuff, I told you work smarter, not harder. Okay? So if I'm looking at x squared plus y squared equals 13 and y equals x minus 1, which equation, which variable would you solve for?
Y.
Because it's already done for you? Yep, okay. What would another one possibly be if you didn't like solving it for y? What would your other option be? Which equation? Second equation for x. Okay? Right? And I say that because I'll show you in the next example why we wouldn't want to solve for y, or why it's better to solve for x, or you know what I mean? Okay? So I'll show you that in the next example. Okay? But so in this particular system, we're going to solve the second equation for y because it's already done for us. Okay? Step number 2 says, now what you're going to do is you are going to substitute that into the other equation. So my other equation was x squared plus y squared equals 13. But y is now x minus 1. Step number 3 says we need to solve that equation, okay? Which means I'm going to have to distribute or multiply that x minus 1 quantity squared. Okay? Now, if you are a big fan of just doing it your way, you would probably get the fact that x minus 1 quantity squared is x squared plus 1. Because you would square x, and you would square negative 1, and you'd get x squared plus 1, and you would keep on sailing through life. Okay? The problem with that is that's bad math. Okay? Because x minus 1 quantity squared is really x minus 1 times x minus 1. And x minus 1 times x minus 1 is x squared minus x plus 1, which makes x squared minus 2x plus 1. Okay? So this becomes x squared plus x squared minus 2x plus 1 equals 13. Okay. Can we combine like terms? Yeah, okay. When I combine those like terms, does my squared term go away? No. So because my squared term doesn't go away, what do I got to do? No. No. Well, I would put a coefficient in front of it, but there's something else that would be the next step in solving. No, because there's an x term, so I can't isolate. If there wasn't that other x term, yes, then I'd get all the x squareds on one side and all the numbers on the other. Okay, but I got an x squared term and I got an x term, which means that my equation has to equal, in order to solve it, my equation's got to equal 0. Yep. Okay. So at the same time, I'm going to subtract 13. So then I get 2x squared minus 2x minus 12 equals 0. Two, negative 2, and 12. What pops for you on that? What about the 2?
You can take it out of all.
So we could divide everything by 2, right? Okay. So if I divide the first term by 2, that gives me x squared. If I divide the second term by 2, that gives me minus x. And if I divide the numbers by 2, that gives me minus 6. And all of that is equal to 0. am I going to solve this one now? Say it loud. Factor it. Are there two numbers that multiply together to be negative 6 and add to be negative 1? Two numbers multiply together to be negative 6 and add to be negative 1. Negative 6 and 1 multiply together to be negative 6, but add to be negative 5. What you mean? Negative 3 and positive 2 multiply together to be negative 6 and add to be negative 1. So this is going to be x minus 3 and x plus 2. Still not done yet. And x equals 3. So like I said, those two factors equal to 0. So I get positive 3 and negative 2. Okay? Agree with all of that? Okay? Love it. So now what we have to do is now, and I extended, I brought down a copy of low battery. I should plug in my computer. There we go. So what I did is I brought down the original equations. And the reason that I brought down the original equations is because for x equals 3, I have to plug that back into both of my equations. That's the tweak on the conic or on the quadratic systems of equations. Is once you find a variable, you have to plug it back into both of them. Okay? So if x is equal to 3, then I get 3 squared plus y squared equals 13. And I get y equals 3 minus 1. 3 squared is 9. So this is 9 plus y squared equals 13. Subtract 9 from both sides. Y squared equals 4. Square root both sides. And I get y equals plus or minus 2, because I'm taking the square root and I'm solving. So based off of that, I would have a possible solution at 3 comma positive 2 and 3 comma negative 2.
Why did you minus 9 instead of minus 13?
Because I wanted to get the y squared by itself.
Didn't you say you have to have the equation set equal to 0?
But you told me that if we have just the squared term, we can get the squared term on one side and numbers on the other. Right? Yeah. So that this would be one of those cases where in the up above, we had that minus 2x part, which prevented us from doing this. Here we don't have that, so we can do that. Okay? Yep. Okay. And then over here, I just get y equals 2. So that takes this one and it throws it out. Okay? Now I've got to do that exact same thing, but now with x equals negative 2. So now I get negative 2 quantity squared plus y squared equals 13, and I get y equals negative 2 minus 1. Negative 2 squared is 4, plus y squared is 13. Subtract 4, y squared is 9. Square root both sides. y is plus or minus 3. So that tells me I've got possibles here of negative 2, comma positive 3, and negative 2, comma negative 3. This one tells me y equals negative 3, so that kicks out that one. Okay. Now, my question to you is this. X squared plus y squared equals 13. What is that?
Circle.
The circle? Okay. Explain to me more about that circle. Yes, you don't have to tell me both terms are squared. There's an addition sign between them and the coefficients are the same. That's why we know it's a circle. I want to know about the circle. Where is it centered? What's its radius? What do you got, Sam?
0, 0.
Center is 0 at the origin. Okay, right? And the radius is
6.5? Well, you said it was 13, right?
6.5? Too big.
You did it.
Why?
You got
That's
it right.
half.
You just turned it in half to square root. Oh, you read the right idea.
Yep, exactly. Explain that because Colin's thinking the same thing.
She did half instead of square root.
Square root to find the radius because 13 is r squared, which is not half. Square root is not half. Okay? So square root of 13 is approximately what? Well, what's the square root of 9?
3,
What's the square root of 16?
4,
So where's the square root of 13?
3,
A little bit more than 3.5, right? Okay, right? So 1, 2, 3, 4, 1, 2, 3, 4. So it's somewhere in there, right? Approximately. Okay? Y equals x minus 1. What is it? The line. Talk to me about the line.
It has a slope of 1.
What does that mean?
Goes up over 1.
I don't know over as a direction.
Like up 1 to the right 1.
Up 1 and right 1. Okay, what else do we know?
Yeah.
Y-intercept is negative 1, right? Okay, so it goes through here and it goes through there, and so then it goes like this, right? Yeah? Okay. Would it fit that this point right here, that point right there, would that be about 3, 2? Yeah. Would it fit that this point down here would be approximately negative 2, negative 3? Yeah. So the answers to this quadratic system are 3, positive 2 and negative 2, negative 3. Right? Okay. Now, let's check it back in both equations. 3 squared is 9. 2 squared is 4. 9 plus 4 is 13. 2 is 3 minus 1. 3 minus 1 is 2. 2 is 2. Check. The purple one checks out. Orange one, negative 2 squared is 4. Negative 3 squared is 9. 4 plus 9 is 13. Checks out there. Negative 3 is equal to negative 2 minus 1. Negative 2 minus 1 is negative 3. So the orange one checks out too. So it checks out both mathematically by plugging them back into both equations, and it checks out by graphically, okay, by just the quick little sketch of a graph that we made. Questions on solving by substitution?
Do we have to graph it every time? Do we have to show a graph every time? Unless there's graph paper.
I mean, well, but how hard was that? You know what I mean?
Yeah.
And then we know, because what are the different ways that a line could intersect a circle? So tangent means it touches how many times? Once. Okay, so a line could intersect a circle twice, once, or twice, once, or not at all. Right? Okay. So a quick little sketch tells me, yep, it intersects twice. I got to get 2 points. There they are. Boom, checks out. Okay? Okay. So I had told you before that I was going to show you in this example why I wouldn't solve this one for y. Okay? So if I'm doing substitution, okay, I could pick solving for y, right? Okay? But then I'd have to go back and I'd have to plug it in here, and I'd have to go back and I'd have to plug it in there. Whereas if I solve this one for x, I would only have to plug it in one spot. Right? So what I'd like you to do now is I'd like you to solve this quadratic system of equations using substitution. Okay? So I would solve this equation for x. Then I would take that x, or that, and I would plug it back into the other equation. So that's going to give me y squared minus 10y minus 8 times, now that's going to be 8 minus 2y plus 57 equals 0. Do a little distribution. So then that's going to be y squared minus 10y minus 64 plus 16y plus 57 equals 0. Y squared is by itself. Negative 10y plus 16y is plus 6y. Negative 64 plus 57 is negative 7, equaling 0. Two numbers that multiply together to be negative 7 and add to be positive 6 are positive 7 and negative 1. So I get y equals negative 7 and I get y equals positive 1. That up a little bit. Okay. So if I'm looking at y equals negative 7. Negative 7 squared is 49. Negative 10 times negative 7 is positive 70. Minus 8x plus 57 equals 0. So that gives me, what's that, 119, 176. Equals positive 8x if I move the 8x to the other side. Divide both sides by 8. Should be 22. Yep, 22 gives me x. Okay. Plug it into the other one. X plus 2 times negative 7 is negative 14. Equals 8. x equals 22 there also. So that gives me the point -7. Oops, nope, tap the brakes. Doesn't give me -7. Gives me the point 22, comma, -7. And that's a solo one because we didn't get plus or minus anywhere. Okay. Then I've got to do y equals 1. If I put 1 in there, 1 squared is 1. 10 times 1 is 10, so that's -10 minus 8x plus 57 equals 0. So that is going to be -948 equals 8x, so 6 is going to equal x. And then if I put it into the other one, x plus 2 times 1 is 2 equals 8, so then x equals 6. So my other one is 6, comma 1. Okay. Does it make sense that, well, first off, what is this first equation? What shape is that going to be? Parabola. Okay. Opening which way?
To the left.
Give you another chance.
I mean, to the right?
Yep, because when you move the 8x to the other
It
side, it
makes it
becomes positive.
positive.
Yep. Okay. What's the second one? Second one is the line, right? Okay. So I've got a right opening parabola and a line. So the choices are none, 1, or 2, right? And this one just happened to be a 2er. So let's check it. Okay. So 49 plus 70 is 119. Minus 176 is -57. Plus 57 is 0. 0 is equal to 0. 22 plus -14 is 8, and that's equal to 8. Okay. 1 minus 10 is -9. Minus 48 is -57. Plus 57 is 0. And 6 plus 2 is 8. So there are the answers. Okay. Good times. Really went all out with the homework tonight. Okay? Due on Wednesday. Okay? What's up?
Are we turning?
Yeah, I haven't collected those yet. I didn't go around and collect those yet, did I yet?
Nope.
So I'll do that right now while you guys are writing this stuff down. But yeah, I'm going to collect them.